So our last presenter is Sean Lee. He is currently a GIS Senior Project Manager with the Washington College GIS Program. Lynn is a graduate of Coastal Carolina University, receiving his bachelor's in computer science and an MBA in 2014. Lynn has been studying traffic safety and GIS for over 4 years, working closely with Maryland Highway Safety Office and local, county, and state law enforcement to provide statistical and geospatial analysis, maps, and trainings in efforts to reduce fatalities and crashes on Maryland roadways.
Thank you. I hope you didn't say 40 years because it's a little too, haven't been in the game too long. All right. So good afternoon, everyone. I am Sean Lynn. I work with the Washington College GIS Program, studying traffic safety for the state of Maryland. Today I'm just going to go over some visual examples and kind of talk about each of those visual examples. We've had some really great guest speakers here this afternoon that I'm going to try to highlight some of their efforts as it relates to some of the stuff that is being done at Washington College. But just to get a little bit of a background of our program, so a private liberal arts school, one of the oldest colleges in the United States. I think we're ranked number 10. It changes every time I talk to someone on campus. Located in Chestertown, Maryland, which is on the eastern shore of Maryland. And for our GIS program, we work roughly with 40 to 60 undergrad students. My group, with the grant that I work off of, tends to work off about 20 to 30 students working on these real-world projects, trying to make real-world impacts. So just getting an understanding of what I work with. So I work with Maryland Highway Safety Office, which is a branch of the MBA, Motor Vehicle Administration. And this is really stands out to what our missions and goals are. We're trying to, if you start from the outside of the square, taking a look at enforcement, engineering, education, and EMS, trying to work with all those groups on the core topics, utilizing coordination, collaboration, communication, on what we call our 6 emphasis areas, which is aggressive driving, distracted driving, highway infrastructure, impaired driving, occupant protection, and bicycle safety. And then at the bottom is where us GIS folks work with is essentially that data, taking a look at crashes, citation, roadway characteristics, drivers, the vehicles themselves, and so on and so forth. So I'm not going to go over the definition of GIS, but I thought this was a great image by the National Geographic, kind of giving you a quick visualization of essentially marrying all that data together, taking a look at multiple things. The last 2 presentations, you saw taking those geospatial data sets, combining them together to essentially get that integrated data design. So I'm going to talk about some of those data sets that we take a look at Washington College. So why is GIS crucial for traffic safety? For me, it's that spatial component, is taking a look at that data spatially and figuring out trends, figuring out a variety of different things as it relates to those individual data sets. For example, we deal a lot with impaired driving, taking a look at things like liquor license establishments and how they correlate with the crashes that are occurring throughout the areas. So for us, when we're taking a look at utilizing GIS, we also deal with our strategic highway safety plans. I know many states that deal with those. We work with our strategic highway safety plans on a state level and local level to provide them analysis, utilizing that data sets that I was just showing you earlier in those target areas, the education, engineering, enforcement, and EMS. So just taking a look at supporting EMS, the 2 that we lightly focus on is EMS and engineering. I know from taking a look at the schedule, I know for us, we have a little bit unique of an edge. We're taking a look at mostly education and engineering as it relates to the data sets that we're dealing with. So it's a different look at of the data that we're trying to review. So one of the things that we do with GIS, and you see a map behind it, taking a look at fatal locations, is taking a look at where these fatalities are occurring, and marrying that data sets up with things like hospital records and those types of things. Supporting engineering. So we utilize GIS to support engineering. In the background of this, I know it's a little dark, they're painting crosswalks, schools. So we work with putting in those locations, finding out where these locations are needed, where these high pedestrian crash rates are, and so on and so forth. Supporting education, we use GIS to support those initiatives. One great advantage that we do have is we go out with our law enforcement. You see the picture on the top. We go out and do DOI ride-alongs. Yes, the students really enjoy those because then you get to see the bad guys getting off the road, is what they tell me. But the thing is, for them, is they get to see the firsthand experience of what these officers are doing when they're going out and doing this enforcement and trying to make improvements to the maps that we're providing them. And then also just educating. This is actually a local event that Noise puts on in this area. It's a nationwide event. And being able to educate the youth, the high schoolers, on the safety of getting behind the wheel and, you know, what are the effects of, I think this one, if I wasn't mistaken, was a marijuana goggles, and figuring out what the influences of marijuana as you're on the roadways. And then our support to our law enforcement, taking a look at things like high visibility enforcement and providing that information. So I just wanted to kind of briefly talk about that before we go into taking a look at the actual analysis. So just breaking down the analysis, for us at our office, we heavily use ESRI, ESRI. I know that the last presentation was using, I think, QGIS. That was a QGIS. And the presentation before was using ESRI's web app builder. And I'm going to point that one up in the web apps. But for our office, we take a look at taking that GIS data and putting it into these 4 areas: dashboards, infographics, just essentially combining information and data together, the actual maps, and then doing web apps. And if I have time, I've preloaded the application to kind of do a live demo of the application that's being used throughout the state of Maryland. So just a quick, simple look at dashboards. I don't really have too much on this, but being able to present that information. This actual dashboard is taking a look at crime in Baltimore City and taking a look at what's going on that, correlating it by districts. But the other areas that we take a look at is Power BI, Insights, and Operation Dashboards. And this is an example of ESRI's Operation Dashboard. The reason why I don't have too much on this is we're expanding into this area as the technology is becoming more and more available. Insights just for ESRI just became part of the ArcGIS Online suite that it was originally just for the enterprise, the back end of the servers. So taking a look at infographics. So one of the most powerful things we utilize is infographics when it becomes our GIS data. So we're putting our data into many different applications to be able to QGIS, ArcMap, ArcGIS Pro, and then spitting out these reports based off that data spatially. So it's just some of the examples of some of the stuff that we use. We use Engage, Canva, Publisher, just being able to provide just really great visuals and reports instead of just spitting out these just general reports that have just text, a title, and just some general information. We want to capture the audiences every time that we're sending out reports, and we're finding more and more as we send styled reports just like this. Is a front cover for Fort Meade that we actually just sent out, I think it was Monday, I think it was yesterday. This one just got finished. Just being able to try to present that data in different formats instead of just your traditional text. and then also taking a look at time and day. We were just talking about taking a look at data in an X, Y, and Z value set, just taking a look at the X, Y in this example here. So as I was saying before, with the maps, we primarily use ArcGIS Pro. We still are using heavily ArcMap, but at a smaller percentage. ESRI's doing a really great job keeping a lot of the tool sets that were in ArcMap now available to ArcGIS Pro, and there's updates constantly to the software. But we do on occasion use things like QGIS and other data sets. But this is just an example of us taking a look at that data more visually and trying to captivate our audience, trying to break things out, more colorful. A lot of times when we do color data sets, sorry, it's hard to see some of these colors. When we are taking a look at some of these products that we're using things like Color Brewer to be able to try to figure out what are the best combination of colors to be able to use. We had a really great experience with a student this summer. He was colorblind. So we learned a lot about our products because of his disability. It really helped us out try to figure out how to style these maps accordingly to someone who may have disadvantages when it comes to looking at the product. And surprisingly, one of the things that we had a summer institute and talked about, we had a guest come in. They also talked about when you're producing things like maps, there's a lot of colors. Does anybody still print out maps, their office? Raise your hands real quick. Only a couple people? Okay. I deal a lot with law enforcement. If I'm lucky, I get them to open up the web application, so a lot of our products are print out. But for those who are printing out maps, print them out in grayscale. You'll see some things that you wouldn't imagine when you're taking a look at that, taking a look at those products. The other thing that you can see here when we're taking a look at the visualizations is things in ArcGIS Pro. It's a lot easier to do things like shading. Being able to kind of shade off that noise of an area, those base maps, and those sometimes those base maps get really heavy and there's a lot of granular detail, which is very good when you're going in and taking a look at those zoomed in areas. This is Salisbury, this is the Annapolis area. But sometimes it's not when you're doing a product that maybe just an image or taking a look at it in a static way. So then I wanted to take a look at infographics and maps because for us, we do a combination of both when we send out products. This is a real product that we sent out to PG County. If you're not from the area, it's right outside of the city as you're going east. It's Prince George's County. And just being able to take a look and stylings maps to be able to captivate the audience and actually point out some of the things that we want them to see that we saw from putting them in the software and being able to digest that information, just like you can see the percentages up here. If I can read them quickly. One is taking a look at impaired crashes versus e-ticks. So the number on the left is the e-ticks stops, which that's just a citation stop. And then the 63% is the crashes, and that's all in a radius near liquor license establishments, and then providing that information. And then just going through the rest of the product, just taking a look. I thought this was a great sample of a full product for this presentation, as this was just released at the beginning of this month. But it's similar to some of the other analysis that we do in our office. Taking a look at the data, taking a look at the variety of different data and seeing what patterns visually there are. This one here is taking a look at the percent change, and that is a tool. You could do it by hand, but there are tools in ESRI that you can take a look at the percentage change. It's in the public safety tool set, if you're familiar with the ArcGIS suite, and taking a look at the correlation of crashes between this one was taking a look at 2 years versus 2 years, so a 4-year span. and figuring out where those crashes are occurring at higher rates. So, and then this one is just taking a look at those notable areas based on a variety of different things. This one's tying in liquor license establishments. For other data sets that we use, taking a look at things, and I believe the next one is what I wanted to point out. Perfect. This one is taking a look. So we went from impaired to taking a look at things like unrestrained and distracted driving, and trying to figure out patterns that way. So for these two, we're taking a look at state routes and rural routes. We're using the models made by USDOT to take a look at crashes that occur and figuring out crash rates on state routes. There is a rural one. We use it. I'm not sure how effective it is as it relates to, because you don't have things like for the state routes, you're using things like AADT, so you're taking a look at that, those annual average travel counts and marrying them up. And then we're able to quickly provide that information of those road intersections on these maps. And then this one here is just start taking a look at our crashes throughout that area. So that one there, that one has tessellation bins, and I'm going to talk about that very shortly. So we do have an application that we use. It's our Risk Analysis of Vehicle Environmental Network. We were just a finalist for an award at the Traffic Records Forum. So we've had the application for almost 4 years. I just wanted to quickly snapshot. So we are using a web server here. This one's the ESRI's ArcGIS Enterprise. It was just server. But the enterprise is now encompassing portal and server. So on top of that, we're using HTML, JavaScript, and a PHP framework called Laravel. This one's a custom application. The presentation that Kyle had done with the pedestrian fatality maps was using the web app builder. There is customization. You definitely could see some of that customization when he went through the map with the widgets. But this one's a pure application that was developed using the JavaScript API language that ESRI has provided. So I've had trouble connecting to the server, so I wanted to quickly show some pictures. I got a couple minutes, so I'll quickly pull up the application for a couple minutes and then take questions. So we take a look at three main things inside of our application, Raven. Is hotspots is the first one, taking a look at as it relates to kernel densities, using the kernel density tool and figuring out where these top locations are for things like crashes. The next one we use is the road segments. It is a little dark, so we like to break down our road segments by 1 mile and essentially do an aggregation of the crash data on top of it to take a look at these trends. If you would see the legend here with the values of it. I did the Annapolis area. One thing to note about the data that you do see on the screen is we've aggregated it by the county level. We have 24 jurisdictions in the state of Maryland, so we've aggregated it that way to kind of give those areas a unique look at. Because since we deal with a lot of law enforcement and education, they're usually county-based, so we want to take a look at just their data. And then the other thing that the past couple of years, if you do follow ESRI and a lot of the data visualizations for GIS, is taking a look at tessellation bins or Hexagon bins. We put Hexagon bins for some of our users. So just being able to aggregate that data in a different level. And as you see here with the data that you see that we've taken a look at overall crashes. Let me see if I got about a couple minutes, 2 minutes. Okay, I can show people the application. I'll stick around afterwards to kind of take a look at that if you're interested. But the application, as you saw here, yeah, they're all at the same level. We have all our emphasis areas, so we're able to break down each of those crash data sets. So we're taking a look at aggressive driving, we're taking a look at impaired driving, all those areas, things like nighttime, motorcycle crashes. We're taking that and providing that back in those GIS formats. So whether it's a dynamic map here or those static products that I was showing you, we provide that to various departments throughout the state of Maryland to quickly come in. The average user time in the application is about 5 minutes, and it's perfect. That's all the time we want them to be in there. Go in, get their information, and then get out and make those impacts on our roadways. So I'll leave it at that. I just want to thank Alicia. She's in another presentation right now. I borrowed some stuff from her from some of the presentations she's done. She's here with me at this conference. But here's my contact information if anybody has any follow-ups. And if you're interested in taking a look at the application, it is a private application, but I'd be happy to demo it to you if for any purposes of taking a look and how does it apply to your respected areas throughout the United States and throughout the rest of the world too. So, is there any questions?
I was curious, the last statement you about 5 minutes, and so this tool is designed to get in, find what you're looking for quickly, and then be able to use it. Is that what you?
Yes.
5 minutes.
Yeah, lucky enough it is I think the last time I checked, which was about 3 months ago, was 5 minutes and 17 seconds. I want to have that average time. Because as you see here, they're not querying anything. All they're doing is turning on layers and turning them off. They can overlay different data sets throughout the whole application. And when they're done, they can print it, screen capture it, whatever they need, put it in a report, go out there and do enforcement on it, go to take a look at those areas for an intersection. We're working with Baltimore County to do pedestrian enforcement, taking a look at those areas that have high pedestrian crashes, grabbing that information. Okay, so then when they go to court or anything like that, they have additional information. So it just depends on the user. But we want them to quickly turn it on. We don't want them querying. We just want them to see the data as it is. We have already done all the processing through many methods. And then providing it for them.
And who did you say your typical user was for this?
For this application, our top is law enforcement, and our second is education. We do have engineers sporadic using the application, and a very small percentage of EMS. But we do get a lot of requests from all four. That would be more of a traditional static product. Yes?
Do you have the law enforcement information, but there is no decided? I mean, for example, from the time a crash happened and to the time when the law enforcement police officer arrived at the scene, do you have such information in the side?
We have the law enforcement information, so I know if it's county, local, state, all of that. I don't know if I have their arrival time, but I have all the metadata that a crash set would normally have. We're getting our data from SHA, and it's a direct feed from Maryland State Police or the data owners. It's coming from State Highway Administration and then directly to us. We normally don't get too much PII, but we do get the respected agency that called because then we do get requests of, I want to only take a look at our crashes because you'll see things such as like a state police are managing these roads, and then your county police are managing those roads. So then we do take a look at that. Okay.
Thank you.
Thank you.
Let's give